Good evening to all of you. Should we start or we should wait for some times? I think participants are coming. If you want to start, then I can start. Otherwise, a little bit we should wait. I am not audible. Bapun, am I audible? Am I audible or not? Okay, thanks. Okay, then I think we should start. Okay, in the last class there were some questions, and first one was, just look here. First question was, this one a basis or not? 1 pi square up to infinitely many, but countable. Okay. How many of you think this one is a basis? Or another one thing, I just want to clear root 2, root 3, root 5, or like a square root of primes. Or this one. Is this one a basis? Okay, Bapun, just unmute all. They are okay. Just make sure that all are unmuted. Yes, Rahul Jha of what vector space? That one of R over Q. Now, just one thing I want to say that we all know that R over Q is a vector space of infinite dimension, right? And in the last class, there was a question whether this one is basis or not. Okay, now we know that Q is countable. Q is countable, and suppose Shuman Pal already, I think all are unmuted now. Okay, you can unmute yourself, and at the time of asking question, you can ask questions, and at this time, please mute yourself, all of you. Now we know that Q is countable, and then suppose one basis of R over Q, we are taking a basis of this set R over Q. Suppose one basis we are taking U1, U2 up to like this. Also basis also countable. We are taking, suppose we are taking this one also countable. Then all the elements of R would be look like some rationals R1, U1 plus R2, U2 plus up to this time plus some here like R star finite, okay, and U star or RK, UK, we can say K is last number, okay. Then from this we shall see that R would be countable, but R is not countable. From here we can conclude that any basis of R over Q is what we can say, any basis of R over Q will be uncountable. And here in that case, in the case of this one, I mean 1 pi square or any power, this sets obviously countable set, this one countable set, this one countable set, right or not? From this, if anyone have doubt about this, let me ask. Okay, if this one, if any basis of R1 be countable, then we know that Q is countable, and the linear combinations, finite linear combination means always finite combinations. Infinite combinations we cannot define. Okay, the finite linear combination, every element of R will be expressed in the finite linear combination of this. Then from this we shall see that U1, U2, UK all are coming from a countable set, and also R1, this R1, R2 and RK are also coming from a countable set. That is why that will make together R is countable. But we know that R is uncountable. That is why no basis of R over Q can be countable. Okay. Then at most, at maximum level, what can we say? We can say that this is linearly independent set, and this can belong to a basis set. This can belong to a basis set of R over Q. Now, can we say that from this, can we express E as a linear combination of those with the rationals and those elements? We cannot express. Okay, that is why E will also be included here. Okay, then again E square, E in power of E also will be coming here. And in this way, we can say that root 2, root 3, root 5, these also will be there. Okay. But in the case of finite dimensional, we will find a basis very easily. But in the case of infinite dimension, it is not quite easy always. In some spaces, infinite dimensional spaces, we can find easily sets. Okay. This basis 1x square, as you all know, 1x square any power up to going to infinity. This will be basis for this space. But over R. But in case of this type, it is very difficult to get a basis. Okay, what maximum level we can say all will be there. Okay, that is why that cannot be a basis. This is a linearly independent set. This one also linearly independent set. This one also belongs to basis, and this one also belongs to basis set. Okay, And any one of you, if you get a basis of R over Q, kindly inform me. Till now, I did not get any basis of R over Q. If any one of you could get basis of R over Q, let me inform. Okay.
Sir, is 1x x square dot 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 is a basis of f over q?
Your voice is so low. Just a second.
Hello.
Yes.
Sir, does this 1x x square x q dot 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 forms a basis for f over x?
F over X means the set of all polynomials. Okay. This set represents set of all polynomials with X, and uh, coefficient we can take from complex numbers. Okay.
Okay.
Coefficients are from complex numbers and in single variable X. Okay. And now there was another questions. Actually, in the last class there was some mistake. Okay. Just I want to say R2 Z2, this is not overfilled. Here, if I give notations like x, y such that x comma y belongs to Z2, then this set will form a vector space over Z2. Over Z2. And in Z2, how many elements are there? Only 0 and 1. Now, what elements can be here? Can you say? Xy such that xy belongs to Z2. And Z2 contains only those elements 0, 1. Then what elements can be here?
0 plus 0 bar.
Yes, 0, 0 bar we are denying. 0, 0, 1, 0, 0, 1,
1 1.
and 1, 1. Okay. Now, this R2 of Z2 over Z2 will form if we define in this case. Okay. And now, this one nothing but just only we know that, as all of you know, maybe know, known to all, that any field, suppose it be a field, then F over itself form a vector space of dimension 1. Okay. And F of dimension 1, again F2 means F cross F, elements are from F, makes a vector space of dimension 2. Similarly, Fn makes a vector space of dimension n over F, same field. Similarly, we can say Zn, if we say Zn, then Zn over Z2, that means this Zn is nothing but Z2 cross multiplication up to n times. Okay. And to be a vector space over Z2 or any Zp, in particularly I am saying about the Z2, for any vector space, for any set to become a vector space over Z2, that set must satisfy one property. That property is V plus V is equal to 0. Why?
Sir,
Yes.
sir, how you have written z to the power n equal to z2 cross z2 cross z2 n times?
No, actually, here just notationally I am saying Z2, it 2 means dimension of 2. Okay. 2-dimensional space over Z2. Okay. This one I am writing just Z2 cross Z2. And here you can say this set is nothing, just Z2 cross Z2. Okay, just this one for notation, and this Z2 cross Z2, instead of writing this one, we can write Z2 here Z2. Any problem?
Sir, but here written z to the power n only.
No, I am saying this Z2 cross Z2 we can write in notation. Many books use these notations, that Z2 over Z2 means 2 times multiplication. N times mean up to n times we shall multiply. Z2 cross Z2. If we put here 3, or if you have problem with this notation, you can skip this one also, no problem. Okay, then you must have to write Z2 cross Z2 each time. Now, just here in the last class, what I was going to prove that if V be a vector space, V be a vector space over Z2, V be a vector space over Z2, and suppose dimension of V is equal to n, then how many elements will be there in the V? Can you say this one?
2 to the power n.
2 to the power n.
Yes, that V will contain 2 to the power n elements. Now I just want to show you some questions. Just have a look on this question. First one, can you give the answers of this one? Look the question 1.
Set 2 to the power 10 by 9 factorial. First one.
Okay. Okay, we shall see this one. Maybe these results may be not known to all actually. Okay. We shall check this one. Just now, just see here. Our V is a finite dimensional vector space. Okay. V is a vector space over suppose ZP. Suppose ZP. Now, if we want to choose a basis, okay, and I think ordered set and simply set, you know all. If I write 1 2 3 and then I write 3 2 1 in the set, these two are same set. But if I say ordered set, these are different set. In the case of ordered set, position of the elements does matter. Okay, in which position which elements belongs to, that is matter in case of ordered set. Now, sorry. Okay, now we are going to find the ordered basis. Basis mean n. Here we are suppose dimension of V is n. Then if we find n linearly independent set, then that will be a basis. We have theorem in BSc course. Now, if I take only one element, suppose I am choosing only one V1 element, and that V1, if I want to choose this one linearly independent, and in ZP there are P elements. Okay, and the Vn, cardinality of Vn, what? Cardinality of Vn is to here P to the power n in that case. Now, if I want to choose V1 from this set, and I want to get this one as linearly independent, one element just and linearly independent, then what we have to choose? Are you listening or not?
The vector element should be non-zero.
Are you listening all?
Even should be non-zero element. If the one element is linearly independent, it should be non-zero.
It should be non-zero. Very nice. Very nice. Non-zero means then we can choose up to this type of element, P to the power 1. This we can choose up to this number of element V1. And if we want to choose V2, V2 is different from V2 such that V2 not equals to alpha V1. Then how many alpha is there?
Exactly P.
Exactly P. Then if we want to get V1 and V2 are linearly independent, then we must have to choose. We have choices P to the power n minus P, right? And similarly, if we want to choose V3 in such a way that V3 not equals to a linear combination of alpha 1 V1 plus alpha 2 V2, and this alpha 1 belongs to 0 to P1 P times, and this alpha 2 also 0 to up to P minus 1 can go. That means this one have P choices, this one have P choices, and these choices don't depend on another one. Okay, that means some noises. Okay, that means we can choose here p to the power n minus p square element. Up to this, continuing like this, if we take ultimate Vn, then that will be our p to the power n minus p n minus 1. Any problem there? You all got this or not?
Yes, sir, got it.
Okay, thank you. Thank you. Then the choices will be V1, V2, V3 up to this. If we want to choose these sets, n linearly independent set, then the total choices will be p to the power n minus 1, p to the
Product of
power
this.
n minus p, up to p to the power n minus p to the power n minus 1. Okay. Now in this set, there are some sets like this: V1, V2, V3, and some may V2, V3, V1. Okay, that means in this collection we get all the ordered basis. Okay, hence the total number of ordered basis of a vector space of dimension n over a field Zp is this form. Total this one actually gives us the total number of ordered basis. Okay, now if we want to get simply basis other than ordered basis, that means I am saying our total ordered basis is p to the power n minus 1, p to the power n minus p up to p to the power n minus p to the power n minus 1. This one total number of ordered basis. Total number of ordered basis. And now if we want to get simply the basis, then the total number of basis, if this number be, suppose this one be our capital M, then the simply basis, number of simply basis, what will be that? That basis will be nothing but m by n factorial. Why is this? Look at here. Someone explain it once again. Okay, just look at the example, it will be clear. Okay, now if we take Z2 cross Z2, then what the elements were? Elements were 0 0, 1 0, 0 1 and 1 1. Okay, here okay, now what's the dimension of Z2 cross Z2? As I said, f n over f makes a vector space of dimension n, and Z2 cross Z2 nothing but just Z2 2 for dimensions. Okay, 2 dimension of Z2 is 2. That means here our n is equal to 2 and p also 2. Zp, therefrom we get p is equal to 2. Now the cardinality of that set, what? 2 to the power just n to the power p, n to the power p, sorry, p to the power n, p to the power n means 2 to the power 2, 4. That's why here the elements are 4, 0 0, 1 0, 0 1 and 1 1. Now can you tell me how many ordered bases are here, or simply basis? If I get b1 first basis, can anyone of you tell me what is the first basis should I choose, or can I choose?
1001.
1001, very nice. Second one,
1011.
1011. Okay.
0111.
Third one.
0111.
01. Okay. 0111. And if we choose at ordered basis, then here another will one come. That one B4 will give just 01 at first position, 10 at second position, right or not? And here B5 ordered basis mean just elements order of the position of the elements we cannot change. Same position means that is a unique. Okay, and here again we shall get another one 1110, and here again we shall get another one B6. B6 means what? Just this one 11 and 01. Okay, then how many ordered bases we get here? How many ordered bases we get here? These all are different. 6 ordered bases. Okay. Now
2 square minus 1 into 2 square minus 2.
you can put the values here in our p to the power n. That case, our what is the value of p? P is here 2. That means if we put here values, then we shall get 2 to the power 2 minus 1 and 2 to the power 2 minus 2. Up to what power will go? Here just one power less than here. Here 2, here 1 means up to this one. Then this one will give 3 and next one will give 2. That means 6. That means we got here how many ordered bases? 6 ordered bases. Okay. Now 6 ordered bases. Of these 6, how many are same actually? If we omit the word ordered basis, we don't want to get the ordered basis. If we want to get only simply basis, then this are same. B1 B4 same, B2 B5 same, and B3 B6 same. That means if we want to get the ordered basis, that means 6 by here what is the n value of n? Value of n actually here 2. That
2.
means factorial. That will give 3. Just this one. This 3 you can consider. This 3 is actually similar of this 3. Okay. That is why we can say the number of ordered bases is this, and the number of simply bases divided by n factorial. Okay. N factorial means dimension of that vector space, that n. And now, have any problem?
Sir, can you go to the previous slide?
Okay. This one?
Yes, sir. Can you explain how P2 becomes that one?
Yes, actually here we want to get n independent set. We are choosing n linearly independent sets. Okay. If I just want to choose one set linear, which should be linearly independent. Here in the vector space Vn, in dimensional vector space, total number of elements, how many? We have proved already this one, that p to the power n elements there. P to the power n elements means including 0 is there. Okay. Now if I want to get one linearly independent set, just one element, one set V1, when this one will be linearly independent?
V1 not equal to theta.
Not equal to theta. That is why we that theta is deleted here. Okay, that is why that's -1. P to the power n including theta, and this one excluded theta. Okay, theta is not here. That is why we can choose this number of elements. In the second case also, second case V2, we can choose only 2 elements. A set with 2, just V1 and V2. V1 and V2 in such a way that they are linearly independent. And we know that in case of 2 vectors, they will be linearly independent if one linearly dependent, if one is the scalar multiple of another, and linearly independent if not scalar multiple. That is why we are taking this relation, not scalar multiple, because we want to get the linear Li set, linearly independent set. That is why. But the choosing of alpha, how many numbers of alpha are here? There is p numbers, 0 to p minus 1. Alpha are scalars. These alpha are scalars, and scalars we are choosing from this set ZP. ZP nothing but 0 to up to p minus 1. up to p minus 1. Clear? That is why here pn minus p. And similarly for the next case, alpha 1 b1 alpha 2 b2, again here p choice, here p choice, that means p square will be not there. And in case similarly if we look this, then we shall get vn is equal to p to the power n minus p to the power n minus 1. Now together if we choose this set n elements, then what the combination we will get? Total number of elements, we can get this one, just product of those. Okay, clear or not clear?
Yes, sir.
Okay, thanks. Now and there is another result, and you can look at the question number 3, this one. Just have a look on that. If up to 5 is equal now I think 1 and 2, the first two part you can solve, and the third one may not be. Can anyone of you know the third one, or can you please kindly calculate 1 and 2, how many results can come if you have time? Do you want to try, or I should leave it?
Yes, sir, I will try.
Okay, then find, just solve first one and second one. Sonu Kumar, did you got or not? Okay, thanks. Just quickly calculate first one and second one, the total number of ordered bases and total number of bases, V10 was it 2. What's the result? Can you tell me?
Sir, can I give the answer of third one?
Yes, obviously you can give.
So third one, answer of the third one is 2 to the power 10 minus 1, 2 to the power 10 minus 2, and 2 to the power 10 minus 2 to the power 5 minus 1, divided by 2 to the power 5 minus 1, 2 to the power 5 minus 2, and 2 to the power
Right.
5 minus 2 to the power 4.
Yes, absolutely right. Very good. You just calculate. I am giving the result for third one. Third one, you can try by yourself how this comes actually. The total number of r dimensional subspace r dimensional subspaces over ZP, and r dimensional subspace means there is a vector space already in dimensional vector space Vn. Then that number will be p to the power n minus 1, p to the power n minus p, and p to the power n minus p square, go like this, and p to the power n minus p to the power r minus 1, and then p to the power r minus 1, p to the power r minus p, up to this product p to the power r minus p to the power r minus 1, this one. This gives the total number of subspaces, r-dimensional subspaces. Okay.
So in that numerator,
Can you, hello, can you explain again, sir?
Which one?
Last one, r-dimensional subspace
Yes.
over
This
ZP.
one, this one actually r-dimensional means maybe there is a suppose 10-dimensional vector space over 10-dimensional vector space over ZP. Okay, over finite field. This all are we discussing over finite field. Now there may be 10-dimensional subspaces, 9-dimensional, or maybe 1-dimensional subspaces. Okay, then total this R belongs to any one of these. Then total R-dimensional subspace, total number. How many number? How many subspaces different? How many different subspaces of that dimension can we get? This will give given by this. Okay, and I am saying you just try to prove by yourself how this result comes, and try to prove as with the help of previous one, which I already proved. Okay.
sir, if you
I'll try.
the last term
Okay,
is
sir.
n minus p to the r minus 1.
Yes, p to the power r minus p to the power r minus 1.
And in the numerator, p to the n minus p to the r minus 1.
So, sorry, where?
So in the where there is p to the n minus 1, p to the n minus p, p to the n
And
minus
last one, p to the power n minus p to the power r minus 1. R.
okay.
And here all are r. R.
Sir, can you discuss the second question again, please?
Second question means which one? This one.
No, not that one. Roman 2. No, long question.
Okay.
The total number of bases.
Okay.
Find the total number.
Total number of bases. Okay. This one actually comes from here. Okay. Total number of ordered bases, we got this one. And here in the ordered basis, same basis may come together. Some of them will repeat. Repeat means maybe V1, V2, V3 will come, and in another set V2, V3, V1 come. But in when we just discuss about the basis, not ordered basis, then actually these two order does not matter. Then these two are same. That is why when we want to find simply the basis, total number of bases, not ordered basis, then this whole number will be divided by factorial n. Okay, and in the example over Z2 cross Z2, we have already shown that.
Sir, factorial n means n for the dimension.
Then for the dimension of V, right? Okay. And now I think calculation you can do by yourself. Okay. Now then you can find total number of subspaces or total number of bases or total number of ordered bases. Now just look at the second questions. Okay, and here in the today's class, actually here only level 2 students are here and level 1 students are there, another class just going on. Okay, that is why here today we shall only discuss about the net related questions. Just look at the question number 2 and try to solve it. Where is the problem coming? I am here to help you.
The answer should be 4, right?
Answer should be 4. Okay, we shall see. Question is clear to all? W1 is the real vector space of all 5x2 matrices such that the sum of the entries in its row is 0, and W2 be the real vector space of all 5x2 matrices such that the sum of the entries of column is 0. Then the dimension of the subspace W1 intersection W2. Just look at here. In case of any problem like a dimension related problem, matrix and dimension, always try to find the dimension in another way, not in as usual way. Just here we have given W1 set of all matrices 5x2 matrices such that the row sum is 0, row sum equal to 0. W1 set of all 5x2 matrices such that row sum 0, and W2 another 5x2 matrices, their column sum 0. Their column sum is equal to 0. Now if I put these two intersection, then we shall get together two condition. 5x2 matrices, those matrices such that row sum is equal to 0 and column sum is equal to 0.
So should be
8. Should be 8.
4.
Sum is equal to 0. Okay. Now here just have a look here. We have this one our 5x2 matrix. Suppose if I choose here one element here, okay, the dimension is nothing but how many elements can we choose independently. Okay, how many elements can we choose independently or freely. Now here if I choose this one freely, this one suppose this one our A, what should be this one?
Minus A.
Minus A. Okay, then from this row how many linearly independent element we can choose?
1.
1.
And if here our B, here
Minus B.
Minus B.
minus B, suppose okay, again one element, here C, here minus
Minus
C,
C.
again one element, right? If I choose here D, here minus D, one element, right? And column sum also 0, then
Minus last element is minus A, minus B, minus C, minus
okay,
D.
should last element is dependent or independent? Can we choose it freely?
No, it is dependent.
Yes, because last element will be just depend on this one. If the sum is 10, then that element will be 10 minus in the bracket A plus B plus C plus D, right or not? That means this element we cannot choose independently. And since again row sum 0, this element also dependent on this one. Okay, clear or not?
Yes, sir.
If any one of you don't get this one, you can ask me. Then the dimension will be what? Dimension will be 4.
4.
Clear to all?
Sir, can we find it
Joy
by
Datta,
using
Joy Datta, you
set
told,
theory operation?
is it clear or not now? Joy, I am asking you, is it clear or not now?
explain again.
You wrote there 3, but answer should be 4. 4,
Sir,
why?
it's a 5 cross 2 matrix, sir.
Okay, now just I am asking this same question in the bigger dimension. Bigger dimension means we are taking in the generalized case what can be. Suppose we are taking W as the set of there 5x2, there was 5x2 in the initial case, but we are taking all the matrices Aij m by n such that those conditions means row sum is equal to 0 and column sum is equal to 0. Then just try by yourself what can be in the same way.
M minus 1 into N minus 1.
In the same way, what you said?
M minus 1.
M minus 1 into N minus 1.
Yes, exactly. Just for others, just look here. Here, if I take A11, A12 up to A1 n minus 1, 1 n minus 1, and then A1 n. This A1 n is dependent on which elements? This one. That means we cannot choose independently this one. Okay. Again, in the second one, A21 will come, A22 will come. That we can choose independently. A2 n minus 1 will come, A21, but this one will depend on these previous elements. Okay, and similarly for others. But up to A n minus 1 1, A n minus 1 1, A n minus 1 2, up to A n minus 1 n minus 1 and A n minus 1 n, suppose this one. Then here also just previous elements will this one last one will depends on the previous ones. Okay, now here this one last element A1n, sorry, AN1 actually, AN1, AN2, and last one ANN. Now this one we cannot choose independently freely, because this one already, as column sum is 0, this one depends on the previous elements of that column. Similarly, this one we cannot choose independently. Similarly, this one also. Okay, then that means we just remove one column, last column and last row. Others, everything we can choose freely. That means total the dimension will be m minus 1 and n minus into n minus 1. This will be the dimension. In the previous problem, there was our W was the subspaces of those elements which was of order 5 cross 2. Directly we can use this formula, and what will be the result? 4 cross 1. You got it or not, everyone?
Yes, sir.
Yes, sir.
Okay. Now we shall go to the next one. Question number 4.
Sir,
Just have a look there.
sir, in one, sir, in the question number 1.
Question number 1.
Yes, sir. There in 1 and 2, there p equal to 2, na?
There p equal to 2 actually. If we in the question, yes, p equal to 2, ZP. The value of p is 2 here.
Okay, sir.
Okay.
And n equal to 10.
Yes, n equal to 10.
Okay, sir. Thank you.
And in the third one, r is equal to 5.
Yes.
Then just go to the question number 4. We shall discuss it now. P is a polynomial with real coefficient, and W is equal to P of B. B is a given matrix. Okay, then find the dimension of the vector space W.
So it should be 3.
It should be
3.
3. Can you explain, Shuman?
Yes, sir.
Shuman, can you explain that one?
Yes, sir. Sir, we can write b square is equals to I. B cube is equals to I. So we can find. So we can find W is equals to A0I plus A1B plus A2B square,
Yes, yes, right.
which spans spanning set will be IDB square.
Yes, yes, very nice. Okay, just see here. What was our matrix here? B or A matrix? What is our B here? B is equal to 0, 0, 1, 0, 1, 0, and 1, 0, 0. What can you say about this matrix?
0, 1, 0 on the first row.
Which type of matrix this one actually?
Nilpotent matrix, sir.
Sir, this is nilpotent matrix index. Sir, symmetric matrix. Hello, sir.
Or
This is
actually this
nilpotent
one,
matrix and the index of B is
permutation matrix, do you know?
Permutation matrix.
It is a symmetric matrix.
Yes, permutation matrix, do you know all? Here actually,
Yes.
diagonal reverse.
just see here. Here in the case of columns, where first column goes actually, first column goes to, if
Three.
just compare
So
with
it
this
is a
one,
back diagonal
compare
matrix.
with this one, the
1 goes to 3.
1 goes to 3, and 2 goes to
2 goes to 2.
2 goes to 2,
And 3
And
goes
3
to
goes
1.
to 1.
3 goes to 1, right?
Order in the matrix is 2.
Order 2. That means if we just do B square, what we shall get? B square?
Right.
2 goes to 2, yes, 3 goes to 1. Then B square equal to, we shall get this B is right or not? Am I right, the correct one? B is equal to 0, 0, 1, 0, 1, 0, and 1, 0, 0.
So there was 0, 1, 0 in the first row.
Okay, 0, 1, 0 in the first row.
So
Then-
1, 0, 0 in the second row.
Then, okay. B should be 0, 1, 0, then 0, 0, 1, and then 1, 0, 0, right?
Yes, sir.
Even the same questions, B, suppose B is given in this way, then what will be the dimension?
Dimension will be 2.
That time dimension will be 2, right?
Span by I and B.
And in that case, 1 goes to 3, 2 goes to 1, and 3 goes to 2.
Sir, please explain how you write this one, this permutation.
Actually, just compare with the identity one. Okay, I3.
Yes.
I3, just this first column 1, with which column it matches with? Similar to which column?
Third column.
Third one. Then 1 goes to 3. And second one, just compare 1, 0, 0. Where is 1, 0, 0 is first one? That means 2 goes to 1. Got it or not?
Yes, sir. Got it.
And similarly, last one is 2. Then this in cycle notation we can write 1, 3, 2. What is the order? 3. Order is 3. That means we can get B cube is equal to I, right? And if B cube is equal to I, in the basis set, what will be there? Just I, B, and
B square.
B square. And the dimension, what is the dimension should be?
3.
3.
Is W is isomorphic to A3?
In the last one, just question number 4. Understand all? Do you understood all?
Sir, in the question, how P of B is
Explain
defined?
again.
How?
How the P of B is defined?
P of B just a polynomial of degree that. What is the order of B, power of B actually? Maximum power of B. Okay. PB is a polynomial, and what should be the highest power? Here we can see that B square I B square, right? I B square. If I took here B cube, that will be here. That means PB is our just, we can say PX is a polynomial of degree 2. Similarly, this one
P of B
look
is
like,
a polynomial in the matrix B with matrix B.
yes, A0I, A1B, and A2B square. P0B actually look like this type.
Okay, sir. Got it.
If you understood clearly this one, please kindly go to the next question. That one actually just generalization of this one.
Sir, is here PB indicates characteristic polynomial or any polynomial?
Your voice is not clear actually. You can write also in the chat box.
Sir, I am saying that PB is it indicates a characteristic polynomial or any polynomial?
No, any polynomial. Okay.
But when I choose basis as B square,
yes,
it
and simply if I say 1x square, okay, 1x square, any up to up polynomial up to degree less equal degree n, okay, PB a polynomial of degree less equal n, then what is our standard basis? In case of polynomial over R,
1x square,
1x square up to x to the power n. And simply here just instead of polynomial in reals, we just, this is a polynomial in matrix. Okay. Question number 5. Rimi Konokar, n. Think again. Maybe, also may not be.
N minus 1, sir.
N minus 1. Just wait, we shall see what may be the result.
Only n, sir.
Only n.
Sir, it is n minus 1.
Okay, we shall check it now.
Yes,
Sir,
sir,
minus
when
1.
minus 1.
Okay.
So it is 2, sir.
It is 2. Okay, we shall see what the result may be.
Sir, order is n minus 1, so dimension is n.
Or here just look here. Aij is defined in such a way that Aij is equal to will be 1 when 1
I plus j equal to n plus 1.
I plus j is equal to n plus 1. Okay.
So it is answer is 2.
I plus j is equal to n plus 1 and 0 elsewhere.
So it is nothing but the back diagonal matrix.
Yes, sir. It is a back
It
diagonal.
is. So the answer is 2.
Answer is 2.
That is just here 0 0, here is 1, 0 0 in that position, here is 0, just before that 1 in that position it will be
1.
And others everywhere
0.
Okay, if you write, if you got problem, if any problem there to understand this one, just take any 3 by 3 or 5 by 5 matrix, okay, or 4 by 4, no problem. Then you will got that.
So the last one in the first row, it will be in the previous one, no? Because it is in the A1 n position. So 1 plus n, it will be n plus 1. Okay, sorry, sir. I saw the.
Okay.
I did the mistake.
Okay. Then just here, in the case of permutation, we can write it as cycles as 1 goes to where 1 goes to n and n goes to where 1. Okay, this type of two cycles will come, and 2 goes to n minus 1 and
n minus 1 goes to 2.
N minus 1 goes to 2. A similar type. And this one, all of 2 cycles. Okay. This one we can write 1n, and this one 2n minus 1. Similarly, all are 2 cycles. And the order of this permutation will be what? LCM of 2, 2, 2. And in the case of, maybe in the case of when n is odd, then 1 just n plus 1 by 2, one single element may come. Okay, that n plus 1 by 2 can go. I mean, in case of 5 order, 3 can goes to 3. Okay, one cycle of length 1 will come, and otherwise all are cycles of length 2. Then LCM of 2, 2, 2, we shall get 2, and that means our, in that case, what is the question actually? Aij b, that means b is equal to b square is equal to what we shall get here?
B square equal to I.
B square is equal to I. B square is equal to I means just I and b, 2 elements will generate that one dimension.
How will get b square equal to I?
Sorry?
B square equal to I. How will get this?
B square is equal to
I.
Just simply in case of px. Okay. If I say px is a polynomial of degree less equal 5, or px is a polynomial of degree.
For any polynomial, it's also true.
Yes, any polynomial. If px is a polynomial of degree less equal, suppose order less equal, I'm saying any n. Okay. Then what should be it look like? Px should be look like a0 plus a1x plus up to a n x to the power n. And in that case here, just instead of x, we are writing here just b. B up to what? ib. B square is equal to I, since that means 1 up to x. a0 a1x. a0i plus a1b. Okay. Now I think question number very easy. You will after that I will send you those questions, and question number 6 you can try at home. This one very easy actually. Now question number 7 you can solve here. Just try question number 7. And here in case of question number 7, I am telling just to find the maximum dimension and minimum dimension. Okay. don't go through the options what are given there. Just don't look at those. Just find the dimension, maximum dimension what can be and minimum dimension what can be.
Integer between 2 and 6.
2 and
Should we see
2 and 6. 2 to 6.
2 to 6. Okay.
So it is 2 to 6.
How shall we proceed? Can you tell me how shall we proceed?
Dimension of W1 plus W2 minus n less equal to dimension of W1 intersection W2 less equal to maximum of W1 comma W2.
Okay. Any other different approach?
Dimension of V plus W equals to dimension of V plus dimension of W minus dimension of V intersection W. From that can proceed.
Okay.
Sir, if we consider a subspace to be W1 and another to be W2, okay?
Okay.
Then dimension of W1 intersection W2, it should be less than is equal to dimension of W1. And again, the dimension of W1 intersection W2, it should be less equal to dimension of W2. Okay.
Okay.
So what are you getting? What we are getting that dimension of W1 intersection W2 less equal to it should be minimum of dimension of W1 and dimension of W2. Okay. So
Yes.
we are getting that dimension of W1 intersection W2 less equal to 6.
Yes. Right. Good.
Okay. And again, if we use that, if we use if you use dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Okay.
Okay.
Then the dimension of the linear sum that is W1 plus W2, it can be maximum 10, right?
Yes.
When it is equal to V, it is 10. Okay.
Okay.
Then when it is 10, we are getting the minimum number, that is 2, right?
Yes.
Okay, so the minimum is 2 and the maximum is 6.
Okay. Okay.
But
Now,
sir, this,
look.
but sir, this approach by W1 plus W2, sir, what will means? What happens if we take both
Okay,
are?
Kamlesh, just look here, or Shuman, just look here. Here, just we are trying to solve with another approach. Okay. Just here, V is given as a 10-dimensional subspace. Okay, that's when V10. Dimension of V is 10, and W1 is a subspace of V10, right? At any subspace, nothing is given here, so we can take as this one as R10. Okay, and W1 is then W1 is a subspace of R10. That means we can take W1 as this way, x1, x2 up to x10, such that suppose first 6 positions are fixed independently, we can choose. Then x7 is equal to 0, x8 is equal to 0, x9 0, and x10 as 0. This will be our 6 dimensional. Okay. Now just here I am writing, instead of writing x1, x2, I am just writing 1, 2, 3. Suppose this one our W1. 1, 2, 3, 4, x5, 6, 7. Up to what we should write? 6-dimensional. That is why, just look here. and here we can put 0 0 0. Okay, just here 1 x1 x2 x3. I am just writing this one. X, instead of writing x1, I am writing 1 x1 x2 x3 x4 x5 x6. All are independently we can choose, and then x7 0 8 9 10 all are 0. This one our w1. Okay, and now w2 we can choose different. W2 must be different from w1. Okay, if we again choose 7 0 8 0 9 0 10 0, that will be identical space. We don't want to get that one. Then to get the maximum dimension, what can we do? We can do here 0 here, and maximum common condition. Common condition means where x7 0, here also we are taking x7 0, x8 0, x9 0. Since the space w1 and w2 should be different, that is why we are taking here 0, and here our this one element x10, this one not 0. Okay, and then 2 position, 3 position, 4 5 6, those position, in those positions here what we can see, these positions are common actually. Okay, in w1 intersection w2, in case of subspaces, when we put conditions intersection, that means both the conditions will be hold. This one position 0 means in the intersection position that whole will give 0, and this one also gives 0. Freely how many we can choose? Just this 2 3 4 5 6. How many elements are here? These elements we can choose freely. Okay, for maximum dimension 1 2 3 4 5, that means maximum of dimension w1 intersection w2 will be our nothing but 5. Okay, and in case of minimum, to get minimum dimension, what we shall do? Just 1 2 3 4 5 6 our w1, again 7 0 8 0 9 0 10 0, and in that case for minimum dimension we shall get the common portion independent one, very minimum, very low number of element we can choose. We want to choose low number of elements freely. That is why we are putting here 0 0 0 0 4 0 here, and then here the number x5 x6 7 8 9 and 10. In case of intersection case, this condition will be 0, this one 0, this one 0, this one 0. Now how many we can choose freely? Just x5 and x6, that means 2. Okay, that means minimum dimension of w1 intersection w2, what will be it? This one, minimum of w1 w2 here 2. Okay, just any big problem can given to you very easily. In this way you can solve. You got it or not?
Yes, sir.
No, sir.
Yes, sir. Not clear.
Clear? Okay,
Yes,
then
sir.
if it is not clear, then you can ask me, and if it's clear, then we can proceed to the next one.
It's not clear, sir.
Okay, why is the problem?
If you can repeat it, it will be helpful.
Okay, if it is not clear, for those it is not clear, just look at here. I am telling just one thing. R3 we are taking as our V. R3 means XYZ such that XYZ belongs to R. This one our R3, and W1 we are choosing in such way. We are choosing W1 such that XYZ such that XYZ belongs to R and X is equal to 0. Okay, and W2 we are choosing in such a way that XYZ such that XYZ all belongs to R and Y is equal to 0. Okay, then if I want to get W1 intersection W2, then what we shall get? If we want to get W1 intersection W2, what we shall get? We shall get nothing but this one XYZ such that XYZ all belongs to where? XYZ belongs to R such that X is equal to 0 and Y is equal to 0. Yes or not?
Yes,
Yes or not?
sir.
W1 intersection W2, we shall get this one, right? In the similar way,
Yes.
in the similar way, we just take here x1, x2, x3. That means these are freely we can choose, but these are 0. That means x7 0, x8 0, x9 0, x10 0. And to get the maximum dimension, that means maximum how many elements we can choose freely. That is why we are the zeros we are giving at common portion 0, maximum 0 we are putting here. That means 0 0 0, maximum how many 0 we can put here? 3. If I put here x10 in place of x10, if I put here 0, and here must be 6, since 6 dimensional subspace, here must be, this one must be non-zero element then, and then this w1 w2 will be same one, identical space. But we don't want to get identical space, these are different space. That is why we have to take maximum common portion, which we can take here this one, and then 0 here, and then here, and 3 element here. And in the intersection portion, since intersection portion means this and this equal to 0, that means x10 in position, this one will be 0, and this one will be 0, first and last position will be 0. And then what we shall get? Maximum this 2 3 x2 x3 x4 x5 and x6, this 5 positions element we can choose freely, right or not? Okay. In similar way, to get the minimum dimension, we are common portion, we want the common portion of 0, we want minimum number. That is why in the free positions places we are putting 0 this time, 0 0 0 0, first 4 position 0, and then this, since 6 dimensional space, 6 ordinate must be non-zero. That is why x5 6 7 8 9 10. And now how many places are we can take freely? These two, x5 and x6. Clear or not clear?
Clear.
Is it clear?
Yes, sir.
Okay. Then just one question. Suppose I am telling V is a n-dimensional space. If this one is clear to all of you, then just give me one answer. V, dimension of V is n, right? And dimension of W1 is equal to dimension of W2 is equal to m. Okay, then what is the maximum dimension of W1 intersection W2?
It is m minus 1, sir.
This is
m minus 1.
Yes, very good. This will be m minus 1. Okay, just in the same
Sir,
way.
but it is not mentioned that.
Sorry?
W1 and W2 are distinct. It is not mentioned here that
But in the
W1 and
question,
W2 are
if
distinct.
W1, W2 not mentioned that they are distinct, then you can take that 6 included. Here one will increase, here one will decrease. For minimum, one will increase. Maximum, sorry, for maximum one will increase that case, and for minimum one will decrease. That means 1 to 6 will be that in that case. If you take same space, then what you shall get? In case of x10, in place of x10, put here 0. You will get 6 dimension here, maximum this, and for minimum again, for minimum
minus n.
that will be 1. Okay. Clear to everyone? You can, that time that will be m minus 1. I think this one all of you will get. Question number 8. Just tell me, subspace will form, obviously, no problem. Just give me a basis.
So 1 0 0 0 0 1 0 0.
Now you are saying about row wise or column wise? In first row,
1
First
0.
row 1 0.
yes, 1 0.
Second row 0 0. 0 1. Sorry, 0 1.
0
No,
1.
0 minus 1.
Minus 1.
0 minus
1 0 0 minus
Row
1. Sorry,
wise
sir.
1 0 0 minus
Yes.
1.
1 0
Second
0
Another
minus 1.
is
0 1
0 1 0 0,
0
and third one is
0
0
0
0
0 1 0.
Okay, that means you are
1 0.
first one should be
1 0 0 minus 1.
1 0 0 minus 1 a into this one
Second,
actually
So
plus
second
b
is
into
0 1 0
1
0.
0 0. Okay,
And third one 0 0
Third
1
one
0.
0 0 1
0
0
0.
1
1
0.
0.
Then this will make this special dimension 3, right? Also dimension from here you can say dimension here 2 element from this two we can choose this one 2 element, and from here and this one dependent, so dimension is 3. Also you can calculate in this way. Okay, now I am asking one important question actually. Suppose our V is this one, m n cross n over C. Okay, and a set S is given like this, and A another n by n matrix, A belongs to V, and I is equal to A0 given, then A square and A in a square minus 1. Okay, the dimension, what is the dimension of this space? V m n cross n over C
n square.
n square. Okay, now A be any element of that V, and S is another set, just like the power up to n square minus 1. Actually here total number of elements are n square. Okay, now question is, does is A basis of V over C? If yes, then why? If not yes?
No, sir.
No, sir, it does not form a basis.
Does
Because
not?
we can say it by the characteristic equation. Because always a to the power n is equals to I.
Okay,
So
very nice.
maximum dimension is n.
Maximum dimension is
N.
n.
So from this set S, only n elements are linearly independent.
Okay.
Maximum.
From the characteristic equation, what can we say?
A to the power n is equals to I.
Yes. A to the power n. No, actually
How
from
can you say?
One can say A satisfies its characteristic equation, whose order is n.
yes. Just look here. If since A is a n by n matrix, then the characteristic equation of A, what will be the characteristic equation of A? That will give A minus lambda I is equal to 0, right? A is n by n, and that means we can write this one as lambda I minus lambda I minus A is equal to 0. Can we write this one? Just one minus can occur if in the case of n is the odd. Okay, then this one simply we can write lambda n plus a n minus 1 lambda n minus 1 a n minus 2 lambda n minus 2 plus up to what we shall get a1 lambda
A1 lambda plus A0
plus a0 is equal to 0, right?
Yes, sir.
That means here and by Cayley-Hamilton's theorem, what do we know? For any square matrix,
every square matrix satisfies this characteristic equation.
Very good. From that, we can write a to the power n plus a n minus 1, a n minus 1 plus small a n minus 2, capital A n minus 2, and then small a1a plus small
A0
I is equal to 0. From this, what we can say? This is a linear combination of a0, a1, sorry, I, a capital A square dot 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 up to a to the power
n
n.
minus.
This I am saying this is a linear combination of I a square up to a to the power n, right or not? Up to a to the power n, and this linear combination here, the coefficient of maybe all other coefficient may be 0, no problem. But here the coefficient of a to the power n, what is the coefficient of a to the power n? 1. Okay. Then this set is linearly dependent or independent? Which one?
Linearly dependent.
Linearly dependent, clearly. Then, and we know one small theorem that any superset of a linearly independent set is, sorry, linearly dependent set is
Linearly dependent.
linearly dependent. This means this S is our superset of this one our linearly dependent set. S is this one. That means S must be linearly dependent. Clear or
Yes,
not
sir.
clear?
Yes, yes.
Okay.
So how to is linearly independent from one into a?
Now actually here you see simple one, the how we check the linear dependence or independence. Just like this one relation a1 x1 a2 x2 or a2 v2 a2 x2 up to an xn is equal to theta. If the coefficient solving this equation, we get all the coefficient as 0, all ai's as 0, then we say that this x1 x2 up to xn is linearly independent. But any one of them, at least one of them be non-zero, then we say that this x1 x2 up to xn is linearly dependent. Here same case happened. Thus a to the power n, coefficient of a to the power n is non-zero, 1. Okay, that is why we can say this set I a square up to a to the power n, this one is linearly what? Linearly dependent. And we know that any superset of linearly dependent set is linearly dependent. That is why that means we can say S cannot form a basis of this V. Okay.
Sir, here the dimension of B is not n square, it will be 2n square.
If
Here the dimension of B is not n square, I think.
no,
It will be
dimension
2n
of V
square.
is
2n square.
2n square.
Yes, 2n square. Because the field is C.
yes. And
Right.
if we take from R, then that
Then
will
it
be
will be
this.
n square.
Okay, right. But maybe bigger, no problem. Okay, 2n square, what may be? Then we should put here 2n square minus 1, right?
So there, if we use n square minus 1, no problem.
Sorry, Shuman, what are you saying?
Sir, we can
Yeah,
consider
if we write n square minus 1, then also we have no problem.
Yes.
Yes, it will.
That depends on only over the field, which field we are taking. Okay.
Over the field.
Now, I think this one you already know all. Just tell me, okay, in one line. Set of all matrices dimension, all of you know.
Yes, sir.
Okay, then I am not asking about those. Just one. Okay, the last one. Question number 12. Can you give this one? For what real values of A is the set WA is equal to A belongs to CR. CR means set of all continuous functions divided on real numbers. F0 is equal to A. Okay.
Sir, A is equal to 0.
A should be 0. Okay, this one correct answer.
A should be 0.
Okay, now just here I am giving you one more question, just try to solve it. You can write this one, okay? One more question just. Asn is given, Asn set of all n by n matrices such that set of all matrices n by n such that Aij is equal to Ars in the case that I plus j, when I plus j is equal to R plus s, or otherwise case they are different. Okay, Aij will be Rs. This one question maybe in JAM or NET. This comes in some year. Okay. Asn is the set of all those matrices an by n, and those are defined as Aij is equal to Ars if I plus j is equal to R plus s. That means I can say A21 and A12 will be same. Okay. Now Asn forms a subspace of set of all matrices. Now the question is find the dimension of Asn. What should be the dimension of Asn? The question is dimension of Asn. What is the dimension of this one?
Factorial n. Yeah, factorial n.
Sorry.
Factorial n, sir.
N into n minus 1 by 2.
N into n minus 1. Okay, we shall see this one.
Sir, it will be 2n minus 1.
It will be 2n minus 1.
Yes.
2n minus 1. And another one says n factorial on n into n plus something like that.
So it is 2n minus 1.
2n minus
2n minus 1.
2n minus 1. Okay. Yes, it will be 2n minus 1. But just in case of 3 by 3, we can check, or n by n, no problem. Here actually A11, A12 up to A1n, no problem. But here in that position, this is actually A21 position, right? But A21 and A12, these are same. That means this element will depend on this one. We cannot take this one. Again, here is A131 is here, and here is A22. But A13 is nothing but same as A22. That means here this element will come here. This one also we cannot choose freely. In similar way, this one will come here, and this, and only one element from this we can choose freely, A2n. Similarly, in case of here also, this one element will come here, this one here, this one here, last one will come that position, just second last position, and then here A3n position will come. Okay, in similar way, all will be dependent, just in the last one we shall get ANN. And in the first row, we have chosen independently how many elements? N elements, and remaining there one element from each row, there are n minus 1 row, that means n minus 1. N plus n minus 1 means 2n minus 1. Okay, Dimension will be this.
2n minus 1.
Any problem here? Dimension will be 2n minus 1. Okay, clear or not clear? Now, if it is clear, I am just changing this condition. If I change this one as I plus j plus 2 is equal to r plus s, then find the dimension. Now our new condition is this one. Aij is equal to ars if I plus j plus 2 is equal to r plus s, then find the dimension. This one, previous one, in that case dimension is 2n minus 1, and now we have changed the condition to I plus j plus 2 is equal to r plus s. And what should be the answer?
Twice n minus 2.
Someone told 2n minus 2. Is it right?
Sir,
Yes.
sir, will there not be second class today?
Oh, second class will not there. There is no second class today actually. Okay. Today is only one class. N minus 1, 2n minus 2, 2n plus 1.
The 2n
Then look
minus
at
1.
here.
Sir, n square minus n plus 1.
N square minus
N plus 1.
n plus 1. This one.
Yes.
Okay, we are checking this one. What should be the right answer? Now this one, our A11, A12, A13, up to N1n, no problem. All those we can write. Now A21, so this one is dependent with the previous sum element. Ij plus j plus 2, here 2. Okay, that means A21, we can write this one. 21, no problem. But A22, if I write A22, that means in A11, 1 plus 1 plus 2, that will give this one 4. This A11 will depend. this A22 will depend on this A11, right or not?
Sir, can we similar say that A13 depend on A11?
Yes, that also no problem. Just that means here we cannot write any element, and here A what element should be here? 2, 3, but 2, 3 will come here or not? 2, 3, 1 plus 2. Here this sum will give 3, and again with 2 this one will give this one. That means this will come here, and similarly this one. That means in that some element here that will come into one position, this position. Okay, that means in this
Sir,
position,
my question is this: can we write similarly A13 depend on A11?
what you are saying?
A13 depends on A11 because sum of 1 plus 3 is equal to 4.
Okay. This actually A11, this one dependent. You are saying 1 plus 2. Yes, this one also dependent, right?
Yes, sir.
Okay, this one also dependent. This one we cannot choose. Okay, then A11 violet, which elements here? Any other? Then A22, I think here is A23 here, A14 here. A14 is here, right? But A12 will.
Yes, sir.
This one.
Yes, sir. Also.
Then from this one, how many elements can we choose independently? Only one element, right? From first row?
2, 3, sir. 3, sir.
Three
A11, A12, or A21.
A12, okay. A12, yes, A12.
A21.
A1 and
or A21.
there is something element previous one that will come here, okay. Right. From first row, only 2 element we can choose, right? Or something else.
No,
From first row, how many element we can choose freely? Just A11 and A12 or any other element there?
So we can choose also A14.
14. But
A14.
14 will give 5. 14 will
it
give 5.
depends on A12.
A14 equal to A13.
A14.
A12 equal to
Actually,
A14.
14 is equal to just A12
A13.
plus 2. This one. A12 plus 2. A12 already we have here. A12 1 plus 2 3. 3 plus 2 is equal to 5. And A14 sum will be 5. Right? That means this one and this one same.
We can choose only 2.
We can choose only 2 elements. And let me know here how many elements can we choose in the second row? Only one.
Only
Only one.
Yes, sir.
Only one.
Only
A21.
one. Then here
And third, 0.
third,
0.
I think
From-
after some step,
No
all
one.
will be dependent.
From third 0.
0 element here.
Yes, sir.
All 0
No,
elements.
sir.
Above. Yes.
So,
Then dimension will be 3, I think. Maybe check it.
A21 equal to A14.
A21.
Equal to A14.
Yes, A14. Because of this condition.
Dimension will be 2.
Because of this one, A12 is equal to A14.
So dimension will be 2.
No, this A21.
A21 equal to A14.
A14. Okay, 2, 3, right. Yes. Nice. Dimension will be 2. Can you reduce one more?
No, sir.
Okay.
It will be 2.
Okay, fine. Then just depending on the condition, dimension may differ. Okay. Just if I try by yourself at home, I plus j plus 1 is equal to r plus s. Then dimension will come another something. Okay.
Okay, sir. If we consider n is equal to 2, that is the 2 plus 2 matrix. Then
Your
what
voice
will be the
actually I'm
dimension
not getting.
in set?
Sir.
If we take A is equal to 2, that is the 2 cross 2 matrix.
2 cross 2
Then
matrix.
what will be the dimension? Yes, sir.
N equal to, if we take n is equal to 2.
Sir, in case of 2 by 2 matrix, dimension is coming out 3.
No, I am not getting you actually. If 2 by 2 matrix, generally 2 by
I'm
2.
saying that I'm saying that generally it is coming out. Generally, the dimension is 2, right?
Yes,
But
yes.
if we consider a 2 cross 2 matrix, the dimension is going to be 3.
Dimension
Then,
should be 3.
how
Yes,
can
sir.
it be possible?
Okay.
Then how can it be possible?
Okay, let's check just. A11, 2 cross 2. That means A11, A12 we can choose, right? A11, A12 we can choose. Here,
Sir.
A21.
Sir.
Yes, tell me.
Sir,
Sir,
for
in the
n by
previous
sir, for n by
A21
n
there is
also.
No, actually you are saying that this one, in that case, if n is equal to, for this case dimension is equal to 2. But if we choose
Sir.
n is equal to 2, then dimension
Sir,
will be 3, right?
Sir, for n by n also dimension will be 3.
Yes, sir.
Then which element we missed here?
Sir, in place of A14, we can put A21.
In place of A14.
We can put A21 or A12.
Yes,
Then,
A12 we put here, A12.
Sir, A12 equal to 1 plus 2 plus 2 equal to 1 plus 4. So in place of A14, we can put A12 or A21.
Okay, anyone we can put here, no problem. A12
So
we can put here.
Sir, from the first row,
yes,
we can, if we take A11, A12 independently,
yes,
then A13 and A14 repeats itself as A11 and as the values of A11 and A12. But
okay.
when we take A15, we have to choose it
A15.
independently, and 16 also independently. That
Okay.
means from the first n elements, there
Yes.
are NC2 elements. Which
Okay, let's
let's
check then. No problem. Okay, we are going to check this one. Just write it. Just write it clearly. No problem. Okay, just tell me one thing. Here we are writing A11 independently. Freely we can choose this one. Now A12. Any problem choosing my A12? Our I plus j plus 2 is equal to r plus s. If this happen, then Aij is equal to ARS, right? Then tell me here A13 can we choose or not?
No, we cannot choose it
No, sir. It
No, sir.
depends on A11.
A11.
A1. Then A13 goes A13. We cannot choose this one. A14.
No, sir.
Well, it depends on A12.
Because it depends on A1.
Okay. A15 can we choose?
Yes, sir.
No, sir.
A15.
It depends on A13.
Yeah, depends on A13. Then we cannot take this one.
Yes, sir.
And similarly, up to last element, no element will come. Okay.
Yes. Sir.
Up to that means up to this, how many element at most we can choose independently? 2 elements.
2.
And here in that case, A11, A21 can we choose? 21 means 3.
No, sir. It depends on A14 and which depends on A12. If n is greater than 3.
N is greater than 3. But then the condition should be right, n greater or equal to 3. Then this depends on this one. That means here 0. Actually, if this type of question comes in the exam, then there must be some condition will be here. Okay.
Yes, sir. If n is greater than 3, then dimension is true. And
Yes.
if n is
And
less than
n
equal to 3, then dimension is 3.
Greater equal 3, then dimension 2.
dimension 2,
Yes,
and
sir.
if n equals to 2, then dimension is
And
2.
n less than
N
equal to
less than
3,
equal
then
to
2.
3, then it is
3,
2.
then
If n
3
equals to
then
2, then dimension is 3.
Then 3.
also when n is
That means if n less than
for
3,
3
then
plus
dimension equal to 3. And n greater equal to 3, dimension will be 2, right?
N less than 3 means
sir, if we
n
take
equals
n
to
is equal
2.
to 3, then
No,
also it
if
is
n less than equal to 3, then dimension is 3. And if n
3. Yes.
greater than 3,
Then
then
3,
Sir,
then
the
sir,
dimension
dimension
is
is
2.
2.
Okay.
sir, if n is equals to 1, then dimension is 1.
I'm getting
So if n equals to 2, then
Okay.
if
dimension
n
is
is
3.
equal to 3, the
No
dimension is
check
sir,
it
if
by
n is equal to
whatever
3,
may be.
the dimension is coming out to be 2.
And some condition here I am saying that.
Okay. Sir, if
there may
there
be
is
3 conditions, sir.
What you are saying?
There are
Sir,
3.
there may be 3 conditions on n. When n is 1, and n is
Okay, I am
3,
saying
and
that
n is...
you just calculate it by yourself, no problem. And different type of condition may occur. I plus j plus 2 is equal to r plus s, or maybe that 2 may not be in that position. Maybe this may be occur in -2 here. Okay, or -1 here.
Yes, sir.
When you solve a problem, then you should look at all possibilities. What may be occur. Just don't stick on one problem. What different type of possibility, and always try to generalize any problem. If you got any problem, you always try to generalize that one, that up to n dimension or m over n, what can be that one in some bigger space. Okay, then I think we should stop here today now, and in the next class we shall discuss some assignment. Maybe some questions will be uploaded immediately. Okay, and those questions we shall
Sir,
discuss.
can you share the PDF in WhatsApp group? Question PDF?
Yes, obviously in WhatsApp group we shall share that. Yes.
Thank you, sir.
Okay, thank you. Good night to all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, Papan, stop this.
Thank you, sir.
Okay, good night.
Good night, sir.
good night.
Thank you, sir.